Assalamu alaikum. Welcome to World Geography with M.ADNAN. Today's tutorial is related to biomass estimating from NDVI and from soil carbon index. So today we talk about it. As you can see, there is a NDVI range which specify the land covered of their space. As you can see here, sparse vegetation value, this is the reflectance values, okay, and this is in the percentage form. So that's why, and here we use some linear and non-linear equation to estimate AGB with the help of NDVI. So here you can consider these two things, A and B. What is these things? So these are the coefficient of this expression and this formula, and this value will be vary according to the temperate, according to the zone of the world. For the zone of the world, I am going to showing you it's a tropical, temperate and grassland. Okay, so here again the formula is present. So what is the temperate zone, what is tropical zone, and what is a polar zone? So these zones varying with a help with the in the variation of latitude, like from 23 to 23.5 north to 66.5 north, it's called temperate zone, and from 23.5 south to 66.5 south, it's temperate zone. And these are below the equator and above the equator from 0 degree to 23, this is a tropical zone. So obviously Pakistan will be there because this work which we doing and estimating this from Pakistan, Sindh province, Hyderabad. So this will be lie in the temperate zone. So that's why we work on it, and because it's from the 23 from here to 60, so that's why Pakistan will lie here, and we will be use this one formula for temperate, and the unit will be the AGB, which is estimating that is tons per acre. Okay, so now first of all I am estimate this. For the NDVI we use the Landsat 8 data, and here is the band 5 and band 4, where the band 5 is equal to near infrared, and the band 4 is equal to red band of the Landsat 8. So this is our study area, and this is our tile for this. Now I use the raster calculator tool. After this I will be going to showing you how can we estimate biomass of soil carbon. Actually it's about the soil biomass, like a below ground biomass, you can say it. So that's why we will be use for it, which is normally called dead composite matter. So we cannot say this is a biomass, we call it the dead composite below the ground. Okay, sorry, not the below, on the ground. Okay, so below the ground we use this NDVI because it's the NDVI will be showing us on the soil, so that's why it's below the ground, and which we use the AGB for the trees. So it will be arithmetic equation. We will be discuss it in the next tutorial. Now I am going to showing you how can we find it from NDVI. So normally we use here the float, simple formula 5 minus 4, and again divided float 5 plus 4. So what will be it's going to be NDVI of this area. We simple keep it to the Keter forest, and here will be the year 2021, and here we already estimated, but now I will use year 1 to show it difference. Okay, so formula is okay, done, and now I just okay it, for the NDVI it will be calculated. After that I will be showing you how can we find the soil carbon index, which is normally called dead composite method. So it's take time, so I let it escape it. Before escaping, I am going to showing you if there anything is remaining in it. Okay, these I am also discuss what is the zone variation, tropical and temperate forest. So these are all things. As you can see, it's done. Now I'm going to showing you. Okay, so its values, as you can see, from minus 0.28 to plus 0.5. So what is the mean of these 0.5? And I'm also add here the my previous to show the values from here. D it should be the Hewre forest. Where is it? Okay, and here will be the forest AGB. So it's little take time, but in this way I'm going to showing you another thing is that here is some difference in that the formula of soil carbon index. It's not like a NDVI. For it you need to use the NDVI software. As you can see, value will be same for last time estimating and for present. So I am going to show you a formula of SCI. So viewers, as you can see here the NDVI which we already estimated. Okay, so now we talk about soil carbon index. Basically you can say is soil carbon index or organic carbon, which is called a dead of plant and some carbon, because the plant when it's cut off and it's die and it's come to the soil, it will convert it into carbon, because 50% of plant is a carbon. Okay, so we use this formula to estimate these content, these organic matter on the surface of land. So that's why we will be consider it as a dead organic matter. So you can see the value of low soil carbon will be from 0.0 to 0.5, and its value will be from 0.0 to 2.0. So it's on the level of it moderate, high and very high. Okay, so it will be more high values along the river line, because it will be the sandy soil like with the erosion and some dissolvable carbon in the along the banks of river will be found. So this in this parameter you can see these, and for these it should be the forest 0.6, and for the grassland 0.4, and between the 0.4 to 0.6, and for the cropland it should be the less than the 0.4. So that's why I'm going to showing you. Okay, as I'm says, it should be help of NDVI. So if you not have this software, so this parameter will be not done perfectly. So here I'm going to open NDVI software. I'm just going to showing you because I'm already estimate it. Here is it, this one for same this area. Okay, wait a minute. Okay, yes. So its value from 0 to 0 to 2.0. and it takes time to, because it's creating the pyramid of this raster data. It's essential sometime to create a pyramids, because when you zoom in and zoom out, so it will show. Okay, here the NDVI software open, but first I'm going to show. Okay, you can see its value from 0.0 to 2.9. okay, it's almost like this. So I'm just keep it. Hold on. First of all, I'm going to show you how can we make it. Okay, then I'm going to show what is its use. We go to the NDVI, and when we check its formula, here is a formula is that we use the Landsat at these band 5 and 6 with our inner ratio, and these ratio will be multiplied with each other. 5/6 and 7/5, these will be multiplied with each other, so we will get this soil carbon index. Okay, so for the ratio, only for the ratio, you can use the NDVI software, and you can also use the QGIS, but mostly I use the NDVI software. Here I write the band ratio, and before opening this tool you need to call out your file, so it will be easy for you to justify it. But you can also call it from the option of this tool, but it will be in the advanced if anyone here is in the basic. So for them I showing it how can we add the files. Okay, I'm going to the file, then I'm going to my folder where I'm save it the previous year. Okay, the TIFF file, no, not the TIFF file. Where is it? Okay, here this. Okay, so what we need the file change from here, the file type, so only TIFF file will be showing to you. 5 with a control select and 7, 5, 6, 7, as I'm showing you. These are our needed file. 5, 6, 7. 5, 6, 7 is selected. Open it, and simple we will be call out. It will be like here. I'm just showing you how can we add these file in this tool, and the result I'm already estimated it. Okay, here's the 5, 6 and 7. The first ratio was there is 5/6 and then 7/5. So you simple select on this, not on this, by this band. Okay, so it will be come in the numerator, and you can see it from this by, and this the 6, and again click on this band one and enter the pair, and you can check is it okay or not. If not, so delete it and again enter it, or if it's okay, so simple okay it. You can see 5/6. Yeah, it's a 5/6. Okay, so choose the file output where you want to save it. You can see I'm already saved it. And one thing I want to tell you, when you save it, you can simple go to the here. You can see I'm already make it 5/6 and 7/6. When you save from here the NDVI, so it will be in the ENVP format, like a HDR format, and this format will not be supported in the ArcGIS. So for if you're working on the ArcGIS, so you simple open this file format here, and you need to export it. Like I open forest work. You can see I'm already estimated it. So now I'm just call out it again. It will be open easily here. So you can simple file and go to the save as TIFF, and you simple select this one, okay it, and choosing from here the file type diff, and output has a where you want to save it, so you can create so these things you need to done it. When you done it, so you simple go back to your ArcGIS software, and then you can use a raster calculator to multiply these ratios. You can see I am already create here a TIFF file 5/6 and 7/6. This will be not necessary file, this for another file. We just concern about 5/6 and 6/7. So this will be in the TIFF format, as you can see here written TIFF. So I'm just open this file on the ArcGIS to showing this, estimating this values again. Okay, so then I will apply simple the formula which I am showing in the start of the tutorial. Okay, so if this file is not opening here, I mean in a table of contents, so you open the raster calculator, so you simple go to from adding, you cannot add it here because you need to open, so there is no option for input. Simple first add these files, then go to the 5 and 6, 7 and 6. Okay, so this file will become here. You can see now we use the raster calculator, and it's no problem, you can keep it first and you can keep other first, so no problem. For float we use a bracket, okay, and then we multiply again float with this, and we simple keep it here with again and simple okay. So it will be run and the equation will be come here, and then I will apply the final equation to estimate biomass. So viewers, you can see it's done. The old one is here and the new one is here. Okay, so here now I'm going to apply the biomass formula to estimating this. Again I use the raster calculator. So the biomass formula we use for the NDVI, not for this SCI, because it's showing us the dead component, the dead organic, it's not alive things, so it will be in this form. Okay, and for the above ground biomass we will be use this formula, this one. Okay, where is it? Oh no, it's not here, it's there. So this formula for the temperate zone, as we use this value, so we simple change here this will be the linear regression. Okay, and simple we keep it here. Okay, we keep it here, and if the sign will be vary, because here not multiplication sign used, so you can simple use here this one, and with the plus is okay, but NDVI we use like this one. Okay, with this sign. So if it's if there no any error, so it will not be showing here, and if there any error, so it will be showing here. So it will be the biomass of year 2021. Okay, and for the beta correction, for the beta, just for calculating the biomass, you first need then we will apply this. You first need to separate it the value wise, just as you can see, because here also will be the water body, and here also will be the other things. You can see we need to separate these things, these, so we will be get these values, which range is point. So we have a range from 0.3 to 0.5, as you can see. highest value is a 0.5. So we just concern about this area. So we simple clip here. Wait a minute. Window, image analyze, and NDVI, clip this one. Okay. So this value will be, you can see it will be the variation as compared to this to this. So here will be the way to. So viewers, you can see we clip this with the help of this tool, image analyze. Now what we do for it, we can keep this layer on the top, so showing our study area. This for the year 2021, because in 2021 this area will be grow as a forest, so that's why little forest in this area. But if we have image of this NDVI of the year 2023 and 2024, so we will be have this area more abundant of the forest, as I'm going to showing you. So viewer, you can see here I'm going first to show you that the NDVI value range. So for it, our study area, we will be reclassify in these three bases, because we concern about these three values, as our value from 0.3 to 0.5, so we will be divided it into the these two things. Okay, so for 0.5 will be the open forest and 0.7 will be the woodland. Okay, so basically our values is from 0.25, and it will be starting from when we use this tool. Simple, you come to the search, the reclassify tool. Here we use the spatial analyst reclassify tool. Here we keep the click NDVI, and here we look out into the values from where the 0.3 value is started. It will be started from here. So from 1 to 6 we will be delete. From 1 to 6 we will be delete. So you can see it's from 0.3, 0.3, 0.8 and 3.8 to 0.5. So we cannot write here the values name like it's for the grass and it's for open. We will be note down it. We have these two things, grassland and shrubland and open forest. Okay, so 7 will be the grassland, sharp land, and 9 will be the open forest. So simple, we will be okay it, and it should be reclassify on these three classes. And here will be the class another, that is 0, which have nothing we think about it. We not have any from this class. We just concern about these three classes. Okay, 7, 8 and 9, and the values will be according to these things. So you can see here is just a grassland, and very less for the shrubland. And you can see, and these three classes are considered to be the above ground biomass. So what we do, we simply go to its attribute table, open the attribute table, and now what we doing, we also check it for the year 2024, and it's for the 2021. From here we start calculating, start editing this one. We want to editing in this file, so the editing will be start. For this I am going to showing you the area. Continue. I want to delete this because we not need this as a blank, so we simple delete it, and it will be deleted, and simple we editor stop. Okay, so now what we have just you can see we export it. So when we export, so this value will be not there. Before exporting, we will check. Okay, it will be deleted, but I need to reopen it. Have it's in the C folder because I'm not given a path. Yes, it's like this file. Okay, so I'm simple remove from here, not export it, simple remove, and then re-add it here, so the 0 class will be not in it. Okay, so you can see the class 0 will be removed from here as we want, because we not need it. So these things will be, you can see just it's on these class values where be interesting. Okay, so I'm also estimate it for the year 2024, so I not want the video will be going to more lengthy, because it's a very informative, I understand, but I tried to do it fast. Where is it? Is it complete or no? It's remaining. Okay, it's remaining. So okay, in this time I'm going to showing you it's a temporal analysis. Okay, where is it? Where is it? Where is it? Okay, so here is our Google Earth Pro. We open here the file. Okay, recording is start. Yes, recording is start. Okay, so in the E we have a folder for a Akita forest, and here will be we have a shape file. Oh my goodness, is the shape file we have is maybe yes, is the shape file. No, okay, so it will be showing us to here. I'm just uncheck this grid file because it's some make it's blur. Okay, wait a minute. This one. Okay, now I open from here the time scale, and I'm also keep here our study area. Wait a minute. Control O, study file, Akita forest, shape file. Yes, shape file, study area. Okay, no, okay, because we just concerned about this, and I will be showing it here. Okay, and I'm simple go to its properties, style, color field, outline. Okay, or I'm also keep it as a, because the whole forest I'm going to showing you, it will be grow from the 2021. Okay, and in the interface which you sees this of the year 2024. So from now I going to change here the time period 2021, and with month it should be a March. Okay, so it will be in a good view. You can see the forest in just this limited area, the greenish and the forest, the grassland, and not a forest, it's just a grassland. You can see because forest is very less as compared to now. I smoothly change the air. You can see it will be gone. Wait a minute. Okay, and just keep it here. From here I'm change the color so it will be showing more accurately. Okay. This is change now. Okay, it's change. Okay, this is our study area. Concentrate on it, and here I'm also change. Okay, so now just 2020 will be more or less, but from 2021 we start, 2022 it's increases so fast, it's increase. Greenish you can see come in these areas. And now we have also download for the year 2024. So you will be see here the result variation, and we will be estimate from it the biomass and the carbon stock. So okay, so now it's about these, and you can see here the study area. See, a very less in this area will be recorded according to this. Okay, so in this area it will be very less as compared to this, because if you can see from the air, there will be very less. You can see very less is there, only this part have. So now we should also add some more values here for calculating this, because if we check out the values from spatial, because this is a very less grassland here in, you can see with the value 6 we should also be added. If we add from the 5 to 0 and delete these values and simple OK it, and it will be showing us this area also, because now you can see just these areas have a little spacing of it, and if we also keep here, because you can see the value here from 0.3, and sparse vegetations, as you can see, like sparse vegetation and bare soil is from the 0.0 to 0.3. like we need to also clip here the value of because very real the biomass here. So in it we again select also the class 4. Okay, so from class 4 it will be from class 5. Okay, so from class 4 it will be very less. Okay, we should also keep it from this. Okay, from these delete, and from 4 to 9 we keep. Okay, so I hope so this area will be covered, because this area have little bit grassland. Okay, so you can see these areas will be covered by little grassland. Okay, and these are also I will be on the basis of this value. Okay, on this value. So I'm also going to showing you the variation with the air, and now I'm going to estimate from here the carbon stock and the biomass and the carbon stock. So for it obviously I'm use this file, and I'm simple remove from here and start editing the 0 value, because the 0 value we not need it, it's a blank value. Okay, so we simple delete it and editing stop, and again reopen this file by removing from without 0 class. Okay, other file we will be unchecked, so it not make a confusion. So in this way, and now I applying the formula for above ground biomass. So not a spatial tool, Excel will be a raster calculator. So spelling mistakes is there. Calculator. Okay, raster calculator. simple the formula keep here, which we use for, the temperate region, okay, oh god, where is it? Yes, temperate zone, this one. Not with these values, these are just R square, the linear regression values. We don't need it, we just need this impression for tons per acre. Okay, this will be the tons per acre, and here what we keep, we simple static this sign and this file with a plus and this. Okay, so it's above ground biomass, about AGB of year 2021. Okay, and simple. Okay, it will be run. So viewers, you can see it's come, and now what we doing, it's 805.54 above ground biomass in what, in the megagram per acre. Okay, it's a per acre calculation. So now we convert it into the carbon stock, multiply by, because the biomass 50% of plant is carbon, so 0.5 is its carbon. So what we do next, carbon stock CO2 2021. Okay, simple. Okay, so it will be showing us where will be the carbon more and where will be the carbon less. So obviously this area will be, as I am showing you, on the forest, on the trees and vegetation, and similarly here these areas will be showing the high value of carbon stock. So this method will be used to estimate the carbon stock and a biomass with the help of NDVI. These steps you need to follow and you will be easily estimate from it. And the CSI, the SCI index, this is commonly shows us the carbon quantity on the land surface. We don't need any further formulas for estimating it, because it's directly estimating from the formula of indices. So here the value will be, its unit will be the pixel per meter square. It depends on the what kind of raster have the spatial unit. It's in the 30 in the meter, so its area will be meter square, so its unit will be the pixel per meter square. Okay, and these values will be pixel per meter square, and this we will be clipped, and similarly we will be divided it into the with the help of reclassify. Why we use reclassify? Because we use reclassify to identify these values. As you can see, for SCI, okay, I'm doing it in front of you, so that why it will be more showing to you, for which we talk about. It's like a already make carbon in the soil presence, so we will be estimate from here and to justify it. Not image classification, here is a spatial reclassify. Recording is stopped. Yeah, recording is continue. Reclassify. Here I'm just keep SCI, and here will be on the values base. Here one thing I going to showing, it's about that, or maybe its pyramid will be creating here. As you can see, the line will be complete. You can see here. Okay, so values will be generated. So about what value we concern, we concern about the vegetation carbon, carbon. So it will be showing us okay, so the value which have a greater than 0.6 will be the forest, and the value which is between 0.4 to 0.6, this will be the grass, and the value which is the less than 0.4, this will be the cropland. So we will be interested in these values, and we just need these values which is from 0.6 to 0.4, 0.4 to 0.6. Where is it? 0.4 to 0.6. As you can see, just this value, because the other will be the highest value, so we just need these, and we will be remove other also this. We should also keep the 0. If we keep the 0, so what it means if we keep the 0, so we obviously we not need 0 because the value less than 0.4 is there. Yeah, okay, so we also not need this value, so delete. We just only this class, okay, because we also concentrate on it. Okay, simple. Okay, it, so it will be reclassified, and it is showing you where the carbon, so its unit will be the pixel per meter square, and it's already estimated carbon index. So you can see very real is these areas which have, you can see just in these areas have carbon, and this pixel may be something it's depend on the area, how much is it, and you can easily calculate from here its area. You can simple go to add here the table double area. Okay, so it's been not opening the field calculator, because why? It's a spatial unit, obviously it's in the 42. So why not opening wait a minute, maybe I need to reclassify it. So we should be reclassify it by taking its training sample and to convert it into the vector form, and then we will be also estimate its area. So as you can see, we can measuring from here. So it's almost the 30 meter have a carbon on this area. So I hope so this tutorial will be help you to estimating the carbon in the forest or the above ground biomass with the help of NDVI. So this tutorial will be helpful for you in research work, and you can also share it with among your friends, and also subscribe our channel for more informative videos. Thank you so much.